Hello everyone. So now let's look at this worksheet problems. This is for the discrete distribution chapter. Okay, question number 1. A coin has 60% chance to land on head if it's freely tossed. Let X be the number of heads on which it lands in 4 tosses. This is a binomial distribution. So then when we have a question like this, we actually need to look at the 4 conditions that makes a probability experiment a binomial experiment. Then we need to verify what number 1, fixed number of trials. So do we have a fixed n? And the second one is, do we have 2 outcomes? And number 3, independent. And 4, probability of success remains same. Okay, so we're gonna look at each one. Fixed number of trials, n. Do we have the total number of trials? X be the number of heads on which it lands in 4 tosses. So that means n equals 4. No problem. Number 1 verified. And then 2, do we have 2 possible outcomes? So head or tail, right? So 2 outcomes. Only those 2 outcomes, heads or tails. And 3, independent. A coin, whether you for this type of coin, whether you got heads or tails, on the first trial doesn't really affect whether you have heads or tails on the second one. So yes, it is independent between trials. So this one verified. And number 4, probability of success. So right here, we're focusing on heads. So probability of success, that's just probability of landing heads. That is 0.6. 60% remain the same, right? Each trial you got the same, it's the same coin, so it's the same. It's just not a balanced or fair coin anymore. It's a little biased coin that you have more chance landing on heads. That's it. But still is a binomial distribution. Then we can say what? We can say X follows binomial with n and p, right? So this n is 4, and this probability is 0.6. That's question number 1. And then 2, set up the probability distribution and find the mean and standard deviation of X. So yes, it's a binomial distribution, but still is a discrete distribution, right? Binomial is just a special type of discrete distribution, which we can use formula to find those probabilities. We have some good properties that can make the calculation process a little bit easier. Then we have this discrete distribution, and then we use a tabular format to write down this distribution. So we want to state all the values X can take. So X can take what? Heads, the count for heads for 4 tosses. So you can have 4 tails, right? So that means no head. And then 1, and 2, and 3, and 4, right? So 0, 1, 2, 3, 4, those are all possible values for this X. And then the corresponding probability, we can get those easily from the binomial distribution table. All we need to know is what is the n and what is the probability. So n equals 4. So we go to n equals 4, and then the possible values X can take is right here. And then we find the probability we're looking at, probability of success, which is 0.6. And then we can circle this whole column. That is the corresponding probabilities. So we have 0.026 for probability of x equals 0, 0.154 for probability of x equals 1. We have 0.346 for probability of x equals 2. And we have 0.346 for probability of x equals 3. And then the last one is 0.13 for probability of x equals 4. And then, of course, the sum equals 1. And let's verify that. We're going to use a calculator to check 0.026 plus 0.154 plus 0.346 plus 0.346 plus 0.13. So 1.002, that's due to rounding error, and then the sum is 1, so no problem. And then we make this probability distribution table. So we can write down by table, or what? Just by the formula, right? Let's just try one of those. Probability of x equals 2. So that is what? We have n, which is, let's write down the formula. N choose x, probability to the power of x, 1 minus the probability to the power of n minus x. So that is what? 4 choose 2, right? And probability, which is 0.6, to the power of x, which is 2. 1 minus 0.6 to the power of 4 minus 2, n minus x. So we simplify that. 4 choose 2, that is just 4 times 3 divided by 2. And then 0.6 to the power of 2 times 0.4 to the power of 2. Then let's see what it is. Use the calculator. We have 12 divided by 2, that's 6, times 0.6 to the power of 2, and times 0.4 to the second power as well. Then we got 0.3456. And by the table, we have the rounding to 3 decimal places, so that's 0.346 is exactly what we have here. And for all others, you can use the same formula to get the probabilities, but using the table, it'll make the process a lot easier. Okay, after we got the probability distribution, we can then calculate the following probabilities. Probability of x more than 4. Do you have anything there that stays more than 4? No, right? So it's for this example, it's impossible, right? We only toast the coin 4 times, so you cannot observe has count more than 4. So that's just impossible probability of the empty side, which is 0. And then for probability of x more than 1, so then that's what? Probability of x equals 1 plus probability of x equals 2 plus probability of x equals 3 plus probability of x equals 4. Then you can actually use all those probabilities, take sum. And then let's calculate it. .976, or we want more than or equals 1, and we know the sum of the probability equals 1. Then we just actually use that equals 1, the sum of all the probabilities minus the one you don't want. You don't want only probability of x equals 0. So that is 1 minus 0.026, then that is 0.974. And they are the same, and just some rounding arrow. So either way is fine. And probability of x equals 3. So just read the table, right? 0.346. Again, if you want to use the formula, that is what? 4 choose 3, 0.6 to the power of x. 1 minus 0.6, that's 0.4 to the power of 4 minus 3, that's 1. So that's 4 choose 3, which is same as 4 choose 1, right? N choose r is the same as n choose n minus r. So 4 choose 1, that's just 4. So 4 times 0.6 to the third power times 0.4. So then that's just 6 times 0.6 to the third power 0.3456. And the rounding to 3 decimal places by the table, then you got 0.346. Again, either way, you get the same result. Probability of x smaller than or equals 1. So that is the sum of probability of x equals 0 plus probability of x equals 1. So then we have what? 0.026 plus 0.154 that is 0.18. 1 probability of x between 1 and 3. So that's just probability of x equals 1 plus probability of x equals 2 plus probability of x equals 3. So the equal sign here in the inequality is important. So purely more than, that means not include this number, right? And then smaller than or equals, that means inclusive. So then we just need to find the corresponding probabilities, 0.154 and then 0.346 plus 0.346, right? 154. No problem. And then finish the calculation, use the calculator. 0.4 plus 0.346 plus 0. Okay, we got 0.846. Okay, if you go by the exact value, which is 4 decimal places, you have a little different value, a little bit different than this one. That's just due to the rounding arrow, so no problem. Okay, that's question 3. Based on this probability distribution, what is the further calculation you can make? So sometime the question will just directly ask you the probabilities. For example, more than or equals 1, or in between a range. After this binomial n and p is given. So all you need to do is check the table, find the corresponding value, and then find out those corresponding probabilities. Okay, number 4, find the standard deviation of the following probability distribution. So if a tabular form is directly provided, then it's just a pure discrete distribution problem. So this one, nothing related with binomial. We just know that possible values I can take are 1, 2, 5, 10, and the corresponding probabilities. 3 of those are given, but there is a hidden condition. Sum of all those probabilities equals 1. So in this place, we have 1 minus 0.5 minus 0.2 minus 0.1. Okay, so that is 0.2. So we fill that in 0.2, and then verify that again. That's 0.7, 0.91. Okay, no problem. Then we can find go ahead find the standard deviation. But before we can find the standard deviation, we always need the expected value. So that is the sum of x times the corresponding probabilities. And then the first value x can take, that's 1 times 0.2, plus the second one, that's 2 times the corresponding probability, which is 0.5, plus 5 times 0.2, plus 10 times 0.1. So that's 0.2 plus 1 plus 1 plus 1. So that gives us 3.2. That's the expected value. And then we have the expected value of x squared, which is sum of x squared times the corresponding probabilities. Then we have what? 1 squared times 0.2 plus 2 squared times 0.5 plus 5 squared times 0.2 plus 10 squared times 0.1. So we have 0.2 plus 4 times 0.5, that's 2, plus 25 times, that's 5, because 5 times 5 times 0.2, that's 5 times 1, that's 5, and plus 100 times 0.1, that's 10. So then we have 17.2. That's the expected value of x squared. Then we can calculate the variance of x, which is expected value of x squared minus expected value of x, and then after we get that number calculated, squared it, take the difference. So we have 17.2 minus 3.2 squared. So then we use the calculator again. 17.2 minus 3.2 squared, 6.96. That's another important information, variance. We want the standard deviation. So standard deviation of x. Let's change another color, since this is what the question really requests us to calculate. So that is standard deviation of x equals square root of variance of x. That is square root of 6.96. Let's see what it is. Square root, that's 2.638. Okay, that's the answer for this question number 4. So for this chapter, the big question will be something like this. So we have one type of question similar to question number 4, that is more for the discrete, pure discrete case. And then we also have a type of question that is related with the binomial setup. And then we want to figure out the corresponding probabilities. Okay, that's all for this practice problem video. And thanks for watching.